Okay, let's start. The last session of DevOps, we would like to make it one about Android application security. And a better title is basically Android application security for developers. That's really our point, our focus point. So first of all, who is we? My name is Philippe Malbranca. I work as a consultant for a company called IDA Media Foundry. I'm doing Android development, and in the last years, I've been working for a few clients in the financial sector, and that's where I met Tekbir here, Tekbir Dylan. He works at ING Bank Belgium as a team lead. He's done Java for ages and Android for the last years, and always been very active in the security topics in his projects. So first off, security, let's start with a disclaimer. I'm not a security expert, and that's really how we want to do this talk. I'm a developer, and I just want the session to be practical tips, some good practices that you should be able to take into your Android development if you're interested in making it a bit more secure. As our last session of the week, it was a late party for some, so for this last session we will not go very heavy on the code. We show a few examples, but for the people that are interested, we did put our code on a GitHub repo, so we have a small demo application. If you're interested, don't fret too much about looking at the slides. We will just show the important parts of the code. The rest you can check if you want to. So,
okay, so this code, it tells you that it's not possible to have 100% security. It's not, if you want to have it, either you don't have your system or you keep it shut. So basically, it's underlying the fact that there's no 100% security, but it's all about managing risk. So security is about managing risk. When I started developing and when I encountered the security officers and they always come to me and tell me, okay, fix this, I always wondered, why aren't they telling me to fix the other thing? Because they thought that's less risky because there are other factors. It's not only that you have some weakness in your application, but there are other factors which are responsible for the risk calculation. The first one is your assets. So that's like something valuable to you or to your organization. So that's your users, user accounts, money, your applications, and whatever is critical for your business in that domain. It depends upon the criticality or impact on that assets, that if the risk would be high or risk would be low. So there can be assets where the risk is extremely low, and there can be assets where the risk is extremely high. Next up is the vulnerabilities. Those are the weaknesses which can be used by the bad guys to go exploit the assets, and that depends on the exploitability. For example, if there is a vulnerability in your system, and that's only exploitable if you have a physical access to the system, then if that facility is guarded by security officers and so on, so it is less exploitable. On the other hand, if that vulnerability can be exploited externally, the risk is high. The next one is threat. What is a threat? It's a person or a group who has an intention to harm your systems or misuse the assets and so on, or use your applications for the purpose for what they are not intended for. And there, the risk depends on the probability, if the threat will happen or not. It depends. What is the motivation? What is the skill level required to exploit that vulnerability? Or what is the end result, or what they want to gain? For example, they want to gain money, the motivation is high, they want to become rich, or they just want to have fun, then they give up after, let's say, 1 hour, 2 hours, okay, I cannot exploit this application or vulnerability. So after learning all these things, I could understand why they are telling me to fix one point and not at the other point. So the critical was the intersection of all these 3 points where the assets, critical assets have a vulnerability which is exploitable, and the threats are high. So those were the ones which they ever asked me to fix first, and then I could relate it to this risk. So if we look in the mobile space and relate it to these three factors, how do we do in, let's say, mobile or in Android in general? So today, mobile devices all in one device. We have everything on mobile. We have our GPS. We have our, let's say, wallet even, which is very juicy stuff for hackers. We have our camera. We use it as scanner or whatever. So all those things increases the threat probability because there is more return on investment. So these bad guys are going to come and try to look how they can misuse this. And on top of that, Android makes it so secure in the platform itself, so their target would be to look for weaknesses in the application so that those can be exploited. Another factor, it's always out, so it makes it more vulnerable. So it can be stolen, you can forget it on your desk, or you can lose it, or when you're on the move, you always use open Wi-Fi where you don't need to have a password or there, which opens up the possibility of man-in-the-middle attack. So exploitability is high. And the next one is, which is more dangerous, is everyone uses it. So basically, in Android puts lots of security in the hands of the end user, and not everyone is tech savvy to know, hey, why this application is asking me for the permissions of my accounts, or to look into my whatever personal information, why this application needs permissions for that. So that's, for example, if there is a rogue application which is being generated after reverse engineering your application and injecting code which needs more permission, user will not make a difference between a normal bad piggies and rogue bad piggies if he's not expert enough. So it introduces more risk. But the picture is not that bad because Android provides sandboxing, which is more advanced than the traditional system. So every application runs in its own sandbox. So it has a very strong, let's say, security basis. So if you look at the traditional system, it looks something like this. So you have your system resources, and there's a user with UID 123. Then he starts or runs certain applications. They all run with the same permission level. So for example, if there is a VoIP client, and on the other hand, there is a PDF reader, they all run with the same permissions, and they have access to the same resources. So even a legitimate application can get affected because of there are security vulnerabilities in other applications. In Android, it's more sandbox. So each application, it runs with its own user ID. So if you have two applications, app 1 and app 2, they will run with different user IDs in their own sandbox. So they cannot access the resources of the user or the system without the user knowing it. They can only do whatever in their own sandbox. So app 2 cannot go access the files of app 1 if you have done it well. There is a way with which you can allow app 2 to access resources of app 1, that's with the content providers, but that again needs permissions, and user knows it, what he is allowing the application to do. Of course, if you want, you can run two applications with the same user ID, but then you have to make it explicit. So you have to mention in your manifest file Android shared user ID, and then you have to give the shared user ID there. So if you want to prepare for this one, you have to prepare it upfront, because once your application is running with the clients, and later on you introduce this, it's going to break your existing clients. So if you plan that I will release 3 applications which need to run with the same sandbox, which is usually not required because there are other mechanisms for sharing, but you never know, there are always use cases. So make sure that you put it up front in your application when you release it for the first time. So in this way, they both run in the same sandbox, and they can use the same permissions to access the resources. So if a file is created by app 1, app 2 can access that file. Here, try to avoid, when you talk of permissions, try to follow the principle of least principle of least privilege. So don't ask for permissions which you don't need. For example, if you don't need network connection, don't ask for it, because usually if you say, okay, I'm a banking app and I need access to your accounts, user thinks, hey, why do we need my accounts? So try to avoid any extra permissions, because some users are really smart, intelligent, and they don't like to give any bit of extra information than what is required. So that way, if you want them to adopt your application, then please use minimum permissions. So let's talk a bit about, there's another thing. If you include less permissions, for example, your application does not have a permission for user accounts, the bad guys who want to have access to user accounts will not come and try to reverse engineer your app or to get the same, to get to the user accounts because you don't have it. So in a way, it's like make you more safer, or probability of a threat is lower. So there are 4 permission types. You always include, I need internet in your manifest and so on, those permission types. There are 4 of them. One is permission level normal. Those are the ones which are less risky. So for example, which allow access in the application own sandbox, access to the files, so you don't need permissions for that, and user is not asked, okay, he needs to access the file in its own sandbox. There's the next one, permission level dangerous. Those are the ones which you see or which you ask in your applications, which a user sees that, okay, I need to give internet access because this permission is more risky. It can access system resources, or I need to give access to user accounts. It can access user resources and can cause damage. So these are the types of permissions which are explicitly mentioned to the user during install time. And next one is permission level signature. So you all know every application, Android requires that it needs to be signed by a certificate whose private key is with the user. So these are the permissions which are automatically granted to the applications which have the same, which are signed by the same certificate. So for example, there is an app A. It has a certain functionality which requires permission of type signature. And then there is an app B from the same developer or signed by the same certificate which needs those permissions. So these permissions are granted by system automatically to app B. The user is not shown that it's asking access to these kind of resources. And the third one is signature or system. These are the permissions for the applications which are packaged in the Android image. And also it's similar to the signature. So if they are signed by the same certificate, usually you don't need to use them. Always permission level signature is enough to do whatever as a developer you need to do. So we need to, as I said, we need to sign your application. We need to sign our applications before they can be installed on Android system. So there are a few signing tips. It's well integrated in the Android build system, but there are a few signing tips which you should follow. The first one is that you should always protect your keys with the strong passwords, because this is where your reputation is. If your keys get leaked and somebody releases another app with the same certificate, it can cause damage to your own reputation. And the next one is a bit of 4I principle. So never give that control to one person. So I, as a developer, if I know that private key, if I get angry or annoyed with my organization, I can always upload or update apps in such a way that can cause damage to assets of the organization. So follow this principle. There's a very easy way. So you can provide, let's say you store your keys in a key store. So always have a strong password for the key store with the one person, and then a password for the key itself. So in a way, it adds, for example, your key store password is your business organization, and your private key password is with the, let's say, your IT organization, and then you need 2 people always to release an app. It's very handy, and it's very simple, easy to do that. Also, next one, keep your key store in a safe place. Provide geographic redundancy, because if there is a flood or a fire in your building and everything goes boom, So you will never be able to update your application again or install new applications with the same signature or certificate.
Now that we've set the scene for security on Android, it's time to get more practical for the remainder of the session. We've seen the building blocks on Android. Now let's get into some practical details and tips. And we'll focus on 4 areas which we find in most typical applications. First off, we'll focus on the application itself. How can you prevent that people are trying to peek inside your application or maybe try to alter it and so on? Second is, well, most applications will also have some data that they need to store. How can we make sure that nobody can peek at the data when he's not allowed? How can we secure the data? Most of the time, the data gets there through networking, so that's another important topic. How can you secure your network communication? And since we're talking about fetching data from the network, sometimes there are also some tips that you can use on your backend, on your services, to interoperate very well and securely with your mobile clients. So we'll focus on the 4 topics. How can you harden your app? How can you make sure that the data on the device is secure? How can you secure the data in transit? And a few tips for your backend. So first off, if you work with your application.
So it's first about securing the app. That's your app as an artifact, as APK, so that nobody can reverse engineer, repackage with a similar looking app and put some Trojan in it, which can take some passwords or PIN codes of users and so on. So there are so many tools available, which makes it much easier to reverse engineer. There are ways you can fight against it, but you can never win. So you can raise the bar, but you can never say, okay, I'm 100% secure because I have done these steps. So first one is obfuscation. We, as Java developers, I was always told to write as much readable code as possible. So don't write any documentation. Your method should say everything and so on. On the other hand, if you have that in your APK and you decompile, your whole business logic is open and it shows the design of your application. Obfuscation is exactly the opposite of it. So yeah, I think I'm missing a slide. Okay, obfuscation is exactly the opposite of it. It's if you have a class like this, that's what it converts to. So you have funny-looking names, A, B, C. So you can use ProGuard to do the obfuscation. And as you've seen previously, it does not only the obfuscation, it also does the shrinking of your APK, meaning it removes all the things which are not used, all the methods which are not used. That reduces your APK size. And it also does the optimization, so it makes methods private if they're not accessed outside, or make them or remove the parameters if they are not used. So because it plays with the bytecode, so it can does all those magics, and ultimately end of the cycle, you have a smaller APK which is obfuscated. And if somebody tries to reverse engineer, it will look something like this. So, for example, you have log statements all over in your application. Everyone knows that you can use this, which says that no side effects if these statements are removed, and ProGuard will remove these statements from your code. So ultimately, when you will reverse engineer, you will not see this log statements. There is a little catch, which is very important. So for example, you have I'm from financial world or from bank, so I always give examples of account. So if you have an account and you have a method on it, set name, and then you have, for example, you have a debug statement which says secret name is equals to name. So if you use that ProGuard configuration, which I showed you before, what you get is something like this. And here you can see that string is already still present in there, although it's not logged as debug, but that string is still there. So it gives a pointer to the hacker, hey, that's my starting point. From here, I need to go backwards. And so what you do, that's because the compiler does some optimization. So it converts your strings into string builder, and then it appends, and then it does the next statement, which is the log. So log has been removed, but this is not taken off. It stays in your code. So what you do, you can write a little wrapper where you just pass on strings as parameters, and then the concatenation is done here. And on the other side, your configuration is still, ProGuard configuration is looking exactly the same, but with now seeing no side effects of the login wrapper. And now if you obfuscate your code, the same code, it will look like this. So that string is gone. It's no more visible. So the moral of the story of this one is that if you use obfuscation, so make sure that you try to reverse engineer it yourself and see that everything which you want to hide is hidden. So basically, it's not a rocket science. There are tools which you can use to do reverse engineering very easily and look into the code, what it generates.
So if we say you should always try to reverse engineer your own application, let's take a quick look at how you could do that. I'm not going to use some existing application so that I make nobody mad, so I'll just use the demo from Monday's hands-on lab. It's an awesome application that allows me to see all my big bang characters. So what happens if I take this application and I start reverse engineering it? Well, first off, you need to know there are several tools available. The most well-known ones are the APK tool and Dex2Jar, but there's even a tool called APK to Java, which is so simple that even your boss could use it. It's just a GUI. You drop in your APK. It even has a checkbox that says, please generate me an Eclipse project with all the sources, and you're done. That's how easy it is to start reverse engineering an APK. So if we run it on the small demo application, this is what we get. So you clearly see these are Smalley files. That's an intermediary language, but you can very easily identify already all my classes. You see my fragments, you see my activities, my adapter. You even see a maybe juicy class, constance.Smalley. So that could maybe be interesting. Let's say that our application is talking to a backend, and not unlike a lot of REST backends, it might have an API key and a secret. So let's take a look what we already see. If you would take a look in the constance file, we see that this is basically already very, very well readable. It's not Java code. We could go a step further and generate Java code from it. But you see that if you don't take precautions, things like your APK keys, your secrets, all the data that you really want to keep hidden, just stick out in the open. And you saw it's like a 1-minute task to get this far and start looking through your code. So that's why obfuscation is important. But of course, we could have an obfuscated application. We should go a little bit further if we want to hide these things like secret keys and so on. So how can we go about it? Well, there are a few quite easy practices that you can use. And the first off is always think before you start implementing code, do I really need to include this code in my application? Wouldn't it be possible to run my very sensitive, very secure logic maybe on a server? Then you already mitigated the whole risk of people taking a look into your application. So if it's possible, always try to make sure that you run your code on a server. That will make it much harder for bad people trying to take a look inside. But if you can't do it, well, you can start playing around with string obfuscation and string encryption. And you can even start very basic. You can start with base64 encoding. You will see that it's already a little bit harder to look through all your Smalley files and see if you can identify, but you can go further. And a trick that's used quite often too is using reflection. So you can use proxies and all the reflection methods you know. And that creates a level of indirection in your code that makes it much harder for people that try to analyze it. Another tip you can use is, if it's possible, you can decide to write some sensitive parts of your code in native code, which is much harder to debug and analyze than the code that you find in your APK. Of course, you always need to make the reflection. If you do that, and you only put the little piece of sensitive code in native code, maybe at the same time that's like a pointer for people trying to analyze that this is the place to look into. So, as he said, it's always a risk analysis. You always need to see how far you go, but it's something that happens quite a lot. On Dalvik, on the Android virtual machine, you can even load other DEX files and so on. So there are a lot of tricks and tools to play with. Another one is even going a little bit further and doing class encryption. And a good tip for that is there exists a tool called DexGuard, which is very simply the big brother of ProGuard. It's from the same people, so it's all the same configuration and so on, but it's a commercial tool. It's not very expensive, and it's already implementing a lot of these techniques I mentioned on the previous slide. So it's really a quick win if you can go for a tool like DexGuard. And it even has a few tamper checks that it adds to the application. For a small fee, it can really bring a lot of value to your project. Otherwise, you need to start looking up yourself how you can do all these tamper checks. So I have a few remarks still about ProGuard. First of all, start using it from the beginning of your project. If you wait until the end of your project to start making release builds and only then starting to experiment with ProGuard, it can become a little bit difficult because normally if you develop on Android, you always have those debug builds, and by default, then DexGuard or ProGuard is not running. So if you wait until the end of the project, it can become quite a burden then to make up your whole ProGuard configuration. The second tip is, each time ProGuard runs, it will generate a file with these mappings. So you saw in the example how it went from readable code to obfuscated code. Of course, that presents you with the problem that if you get a stack trace or so for an application that's been obfuscated, well, how can you go about it? So always, always, always save your mapping file. If possible, try to go for a scenario maybe. If you have a Jenkins build, just make sure that you store it as an artifact too and version it together with your build. So that afterwards, if you get an error, if you get an exception report from a release build, that you can at least figure out again through your mappings what really went wrong. The nice thing is that all the well-known Crashlytics tools and criticism and so on, they all have support for the mapping file from ProGuard. So if you use tools like these to check out the exception reports from your apps, it's very well integrated and you will always be able, even for obfuscated code, to go back. Of course, I already talked about tamper protection. I said that ProGuard has some additional features. So let's see what else is available to try to harden your application. And we have 3 tips. First of all, try to validate, or how can you try to see that somebody is tampering with your application and trying to peek in it? Because if you reverse engineer it, you of course need to repackage it, re-sign it, and then run on your device. So the first tip is, it's possible to check how you've been installed. That could be an indication. Second one is, if the application could detect that it's running on an emulator or running in debugging mode, that could indicate that somebody is trying to tamper with your application, because normally that would not be the case. And thirdly, there are methods which way you can try to determine if the integrity of the APK itself is still okay. So first off, if you know that your application is only going to be distributed on the Play Store, well, why not check if you have been installed by the Play Store application, not being side-loaded or not somebody reverse engineered your application and maybe just switched your ID for your advertisements and put it on another store, for instance. So it's very easy to do on Android because we have a package manager, and the package manager class really can give a lot of information about your application. For instance, if you take a look how you've been installed, if you see that you've been installed by the com.android.vending package, you know that you've been installed by the Play Store. So that could be already a tip that you implement in your application. The second one is, if you could see that you are running in debugging mode, because normally if you release an application, you will not release it in a debuggable mode. Again, the package manager and the application info objects will give you this information, so you can check if the debuggable flag has been set. And a second way to try to determine is, everybody that develops for Android knows that if you use Android Studio or Eclipse or whatever, normally when you start developing, you don't need to think about generating a certificate. That's done for you. The Android tooling generates you a debug certificate. Of course, it's documented how that certificate should look like. So if at runtime you take a look through your signatures, because that's also a particularity of Android, you can be signed with multiple signatures and certificates. But you just go through them, and if you find that one of those matches the debug certificate that standard comes with Eclipse or Android Studio or whatever, you know that you are probably being built in debuggable mode. And then, can you check if you are running on an emulator? Because that's also a good way for people that try to reverse engineer, because they most of the time have a little bit more control over emulators and so on than over a real device. So you could say, I just released my app for normal users, so it would be nice if I could determine if I'm running on an emulator. There's no such method in the SDK, but we can determine it by looking through the build information. If your model or the brand or product contains certain strings, then it's an indication that you are running on an emulator. And after that, I said, yeah, can you try to determine at runtime if you are still the binary that you intended it to be? So, as Tegbir explained, every Android application is signed with a certificate. Well, you could at runtime try to validate it. So how do you do it? You, of course, don't embed your keys and so on. You embed a hash of your key, of your signing key. You embed that in your Android application, and then at runtime, you see how am I running, and you check with the signature that you can find at runtime. If they don't match, it's a good indication that somebody was tampering with your application, took it apart, fiddled a bit with it, repackaged it with his own certificate. So these are a few tips that you can use to try to determine if somebody was tampering with your application. So how do you get the signing key? The real code is a little bit longer than that, but again, through the package manager, you can get hold of your signatures, you generate an X509 certificate from it, and so you can do the check. And then, what's asked often too is, can you determine if you are running on a rooted device? Again, this is just a screenshot from the small demo. Again, you do it by inspecting your environment. There's no safe way or no 100% sure way to determine if you are running on a rooted device, but the most well-known methods to do it is, for instance, you can check if you somewhere on the device find a typical file or a typical binary that indicates routing. For instance, if you find the super user application, it's an indication that you are on a rooted device. And there's a few more things you can do. For instance, if the system partition and so on is read-writable, where it normally should only be readable, then it's an indication that you're running on a rooted device. Now, there are several open source libraries available that are also always updated with the latest status in root detection. There are also a few commercial ones available, but at the same time, I think we should stress that there is no 100% secure way of always determining whether you're running on a rooted device. If the user has a rooted device, he might just as well go a little bit further and try to conceal that the device is rooted. But it can be handy if you try to detect it. So these were a few practical tips surrounding how can you guard the environment where your application is running and the application itself. That brings us to how can you safely store data for your application.
Yeah, so the next up is the data protection. That's basically every application stores a certain amount of data locally, or how do you protect that if you have some local data? The first advice is avoid it if you can. So never put any sensitive information like PIN codes or whatever on the device itself. So avoid it if you can. That's the best advice. But sometimes it's required that you need to store certain information or cache it for the next session and so on. So next one is avoid always external storage for sensitive information, because that's not in the sandbox, so it can be accessed even from other applications, and also externally from your device. If he removes the external storage and plug it in your laptop or somewhere, and then it can be accessed. Next, that's a very good one, which says Android allow backup flag. Usually it comes, by default, it's true. So what it allows, of course, you have to opt in for the backups, cloud backups, but also there's a mechanism where with the ADB, you can take a whole device backup. So if this flag is true, your whole device is backed up and all the participant applications are backed up on the PC or on Mac or whatever. So basically, meaning that your data, sensitive data, which you try to put in a sandbox, is going out. So if you store certain information and you don't want to go outside the device, please make sure that you mark allow backup to false. And I think there is a lint warning also to highlight this one. Yes, that's for the most paranoid ones. So basically in Android, every view has a state saving mechanism. So if you type something in a text box and then you rotate your screen, it implicitly saves your state. And when you are on the other side, then it again recreates that activity and fills that text on the view. So if you really want that whatever user has filled in, for example, in case of banking PIN, that it should not go outside the site or persisted anywhere, so make save enabled for that view to false. So basically, it will not save the state, and on rotation, you have to fill it again. Yeah, always write files, create files with mode private, your settings and everything, database in mode private, so that it is always in your sandbox. Next one, which is also very important, is usually you see in your taskbar of recent application, if you long press, you see a list of applications which have been running behind the scenes or which have been recently run. So you see the screenshots there and you can click on it. So with this flag, you can disable those screenshots or disable that your application displays on insecure displays. So basically, if you're looking at your banking accounts and then your application goes in the background, and then you forget to unlock it to log out, then if somebody even presses on the taskbar, the recent tasks button, you will see in the screenshot all your account information. So to avoid that, put this flag to flag secure so that you see something black, and still you will see the logo, so users can see that it's your banking app, but they will not see any other information. So it basically stops participating in the screenshot. So next one, so people forget their phones on the desk while doing something and they have been called, so always log out if you see certain amount of inactivity after 1 minute, 2 minutes, depends on the usability of your application. So always explicitly after a certain timeout, log out the user from the active session, so that if someone else picks up the phone, he cannot make a transfer to his own account. Next one is about keylogger. Again, coming back to the example of giving your PIN, because that's for a bank account or making a transfer, because that's the one you need to re-enter again and again when you make any transfer, because that's not one which is persisted usually on your device or stored somewhere on your device. So there's always a danger of keyloggers, and there is a new kid on the block. So even usually what people do to avoid that is that they create their own view with their own PIN pad, and then they can use those PIN pads to fill the PIN. But now with the touch sensors, they can even detect with 60% accuracy that which button you have pressed. So if you use that mechanism, you have made a view which is a PIN pad and you have keys on it, always scramble randomly on each run so that they're not always on the same place, so it makes it difficult with such mechanism to detect what the user is pressing. And all these tips, they apply, of course, if you're running on a non-rooted device in a sandbox, but still if there is some data on your device which is in static mode, it can still be tampered with, and that's where the next topic comes in handy.
Now, that brings us indeed to the question about encrypting data. So a few handy reminders. First of all, you need to know that on Android, yes, it uses the same mechanism as Java with Java cryptography extensions and providers that implement those APIs. On Android, that's mostly implemented through Bouncy Castle, the Bouncy Castle library. Good to know is that on Android, they only include a cut down or a subset of the official Bouncy Castle. So it's possible that you might need or that you would want to use an algorithm that's not present on Android. Also, I say the Bouncy Castle library is included with Android. That means that it's bundled with the platform. So that can bring up the whole question. If I need to support old Android versions until 2.3, for instance, then I might have an old Bouncy Castle version there, where I would like to use some algorithms that are part of Bouncy Castle that's only in Android 4.3. So what a lot of people do is they bundle a Bouncy Castle version themselves with their application so that they are not depending on the Bouncy Castle version on the particular Android device. It's quite easy to do. You just need to change up the package names, otherwise you can get in a few of class loading conflicts and so on. But if you want to save the trouble of doing it yourself, there's an excellent project called Spongy Castle, which is basically just doing the work for you. It's a repackage, it's a rename. They provide Maven artifacts and so on for you, so it's very handy. In 2 minutes time, you can switch from the platform-provided Bouncy Castle to a very recent version of Spongy Castle. And basically, it's very simple to implement. It's only one line. You instrument the security class to use your new Spongy Castle classes instead of Bouncy Castle that came with the platform. And at this point, then, you have a recent crypto package for your application. A few other good pointers if you want to work with encryption. There are two excellent libraries. The first one is a SQL Cipher. If you need the database, but you would like to have it encrypted, you can always use the SQL Cipher project. Basically, it's a modified version of SQLite. This project, by the way, is also cross-platform, so the knowledge you gain here can also be applied on other mobile platforms. And it's a drop-in replacement. It's only changing up your import statements, and for the rest, they just use totally the same API. The only thing is, if you open up the connection to the database, you need just to give it your encryption key. But for the rest, it's totally transparent. It's really a drop-in replacement. And from the same people, you have the IO Cipher project. If you ever have the need for an encrypted file container, if you want to store some data securely, then you can use the IO Cipher project. And again, they did just the same. They totally mirror the Java APIs that you know. So it's very easy and very handy to start using. Now, we're talking about encryption. This brings us to the whole question about key management. You're doing encryption, decryption. That needs a key. So what can you do with the key? You could think about, I'm going to store it. I'm going to store it somewhere on my device. I have a sandbox. I will store it somewhere in a file private to my application. Or I could maybe embed it in my source code. But if the whole topic about obfuscation and tampering with your application learned you anything, you should have picked up by now that makes it very easy to extract. So you should never store your encryption keys along with your application. So what can you do with other solutions then? Well, you could maybe think about using a system service so that you're not one responsible, but you delegate that responsibility to a system, which should have a higher security. Or, that's the best solution, of course, is never store an encryption key somewhere along on your device. So what should you do then? Well, you should go towards a system where users always enter a key when you need it, when you need to do a decryption step, for instance. So how do you do it then? Because if you take a look at encryption keys, most of you know that most of the times that's a very long binary string. You cannot expect users to remember a strong, good encryption key. But what do users know, and what are users very much familiar with? That's of course a password. Every user has worked with passwords all the time, so you should try to implement a password-based encryption system so that you generate a strong, good crypto key starting from a password that users can manage. On Android, if you read through all the documentation and so on, you will end up, hopefully with this crypto algorithm. So proper key derivation then, it should have two features. The first one is, it should always be salted, so that you prevent the use of rainbow tables and so on, so that it should never be easy for an attacker to have a whole table where he can look up. And also, key stretching is the mechanism where, if you have an algorithm where you calculate a key, you should try to run it multiple times so that it takes a long period. And long, in this sense, is it should take more than 100 milliseconds. That is to prevent the brute forcing of your keys. So if you make it a computationally hard task for the attacker to do, you're already, again, strengthening your application and your key management. A very good tip is the best documentation you can find on a blog by a guy called Nikolai Yelenkov. I feel that the official Android documentation is letting us down here a little bit. There's very few documentation to find, but he has an excellent blog where you can find a lot of security topics discussed and always very specific to Android. So you will then end up with a key derivation code like this, but let's go a little bit through the rest of the slides. All the iOS people, of course, all the iPhone users here will already been thinking for a few minutes about, but don't you have a keychain? No, we don't have it on Android, but we have something similar since Android 4.3, the key store provider. Of course, until all we developers can start working with Android 4.3 as a base version, we will not be able to use it. But in the future, it's something to look forward to. And another good feature about it is the key store can be hardware-backed. So for instance, on a Nexus 4 device, if you use the keychain or if you use the key store, the keys are stored really in the hardware. On an ARM processor, you have the trust zone model, which basically in the end means that your keys are stored by the hardware. So even if you detect that you are running on a rooted device, but you see that you have a hardware-backed key store, you could still decide that, yes, my environment is secure enough because I have a system service that provides me certain guarantees about security. Again, I'm going to provide a link to the same guy who has lots of practical samples and lots of code on his GitHub repo and his blog. So that's basically it for the data that is in rest on your device. How can you secure it? So next up towards networking.
So next is how do you protect your communication channel, how you make your communication channel secure. So very obvious one, use HTTPS. It uses SSL, TLS to provide confidentiality and authentication. It's not your username password authentication, but this, what I mean by here is that it makes sure that you're talking to a server who you intend to talk to. So it's all using the certificate authorities. So Android packs a lot of certification authorities in the build. We will not go there, but it's basically saying, validating that you are talking to the right server. On top of that, you can do hostname verification. So what it means is that you have a valid certificate and it's issued to a certain host. So if you're asking for example.com, you can do that. the certificate which you receive is valid, but is it tied to the same host, example.com? So you can do hostname verification and then work based on that. Also, there's a process of certificate pinning. As I said, Android packs a lot of certificate authorities. The pinning is a process which limits it. So you can say, okay, I will only allow this certificate to be used, this certificate of a server which I can communicate to. Or you can limit them to certain certificate authorities, like only these I will only trust the certificates of these certification authorities. So that's the process of pinning. Here is how you can do the strict hostname verification. So always set on your URL connection default hostname verifier to strict hostname verifier. So this will match that if you're going to the host and then there is a valid certificate, but that valid certificate was for the same hostname as you are going to.
Now again, practical library, and again from the same people that brought you SQL Cypher and AO Cypher. It's called the Guardian project. They have an Onion Kit project, and as part of it, they have a strong trust manager. So the principles Stegbeer told us about are already implemented in a library where they do strict and full verification of your certificate chain. And also, if you take a look at the security settings of your Android phone, if you go to your settings app, you will see that Android trusts more than 100 certificate authorities. This is just the end of, on my device, it's a list of more than 140 CAs. So if you don't really trust it, if you want to limit yourself to which CAs you use, for instance, if you know that your company always uses certificates from one, you can limit it down to one specific one, or you could also make the, you could start thinking about some of these CAs might be really not trustworthy, because in the last years we've seen that several CAs have been hacked and used to generate rogue certificates. So another thing you can do is, if you use the Guardian project, they only include the certificates that are part of Debian Linux. And Debian Linux is much more conservative in all these CAs that they allow to use. Another one that we see quite often is, how can you go with working with a self-signed certificate? First of all, for a mobile application, if you don't have browsers using the same endpoints, it can be quite okay that you use a self-signed certificate. Or it's also something you often see, maybe you have valid certificates in your production environment, but you don't have it for your testing environment, and so on. If you take a look at Stack Overflow, for instance, what you will see quite often is people suggesting just use a trust manager that trusts every certificate. Of course, never do that and just go a little bit further and implement it as it should be implemented. And a way to implement it is, of course, with certificate pinning. If you know which certificate to expect on the server, well, you can make sure, if you embed it in your app, if you tell your app what it should expect, then it can check it. Very quickly, how you can go about it. If you don't have the certificate on your computer already, you can, of course, always download it with OpenSSL. Then you need to convert it from, most of the time you will have it in a PEM form. You will need to transform it in a bouncy castle container, because that's easy for Android. You just embed it in your raw directory of your app. Then you load it in a key store. It has even a very convenient method where you can work with input streams, so it's just one line. And then you make a custom trust manager where you only will trust your self-signed certificate and use that as the basis for your SSL context. The Android developer side has quite good documentation about this whole process, so no need to go into code here. So that brings us with the securing of the services.
Yeah. So I will start from the other side. Basically, imagine if something goes wrong. So securing services, you all know that it has to be authenticated, authorized, so right people are accessing your services. Okay, that's fine. So what if something goes wrong? Your application is compromised, or something, you find other flaws in your application or in your services. So always, there are a few handy tips. Always use a kill switch for a specific service. For example, if you have a transaction service, so transfer money from account A to account B, so if you see that on some devices, those services compromised, you can switch for that particular user, that particular service. So always include this in your releases. You should always communicate to the user what is going on. So don't just shut down and let him wonder what happened. So tell him, okay, either we are down for maintenance or you have been hacked or whatever you think is the appropriate message. Always let him know what went wrong. And also, if you find, for example, that there is a flaw in my application and you want to release an update, so it takes a while before all the users are upgraded to the new version. So you should include some mechanism where you should tell your users, hey, it's mandatory to update, otherwise you're stuck, you cannot do anything, so that you can get over that flaw and take things back or take control back. And for example, when you are installing your application, you can take some signs if the device is rooted or not while installation, and then later on you find that there is a risk to your application or the data stored on a rooted device. And based on that, you can just switch off your services only for the rooted device, or you can do mechanisms to erase data on the rooted device. So that's why it's very important to have these controls. Apart from that, this REST or any other APIs are similar to web applications, so they have same vulnerabilities. So here I suggest, I will not go into details. There was a very good talk yesterday about OWASP top 10 and SQL injection, validate your input, and so on. So they are all applicable in this scenario also. So you just go on OWASP or you can follow the talk from yesterday, travel in time.
Now, if you've implemented all these tips and basically you really used it as a starting point to investigate more about security on Android, then you could now maybe claim that, yes, we have a secure application, let's release it. Well, let's take a step back, and this is an interesting study that was only released last month, where a couple of university professors basically took close to 50,000 applications in the Play Stores and all analyzed them. And they found from the more than 11,000 applications that used crypto that a staggering 88% of them had implementation faults. So if you work with an Android application, you have some basic security requirements. It can never be wrong to take a step back, and before you release it, reach out and see if somebody can do, for instance, a review. If you're not a security expert, then there's no harm and there's no shame in going out and saying that, please, can somebody validate my application? Maybe you have a dedicated security team in your organization, a security officer to go to. Maybe you don't have it, then you can always go towards penetration testing companies and so on. But it's really necessary, if you're not an expert, that you go out and that you seek validation for all the code you've written. We've talked about a few of the tools. These are basic faults that people are making according to the study. But you should always reach out and try to find a code review for your application, either with static analysis tools or, if possible, a manual review by real security experts. And a design review, how have you put everything together? And reach out for penetration testing companies. We had a very brief intro to reverse engineering Android applications. They will, of course, go a lot further. They will, for instance, also run your application in a controlled environment where they will check what networking operations is the application doing, can we find something, what file system operation are people doing, and so on. But if you're working with security, that's the last tip we wanted to give. If you're not an absolute expert in the field, always reach out and always try to look for extra validation so that you can be secure that you will start releasing excellent, secure Android applications. So that's basically it, a short overview of some practical tips for making secure Android apps.
Thank you very much.